For those of you who may have missed class Thursday, October the 29th, or for those of you who might want to just see the topics covered again, I've done a review for exam 1 as we did in class. So I'll be going through the first practice exam for that purpose. So in the first question, just study these terms. I won't put anything that's not on this list on this question on the exam. All of these are in the index, so you should be able to look them up and find their definitions. Make sure that you do more than just look up the definitions, though. Make sure that you do know the characteristics of, for instance, the mean, the median, the mid-range, and the mode. Which ones are resistant measures of center, which are not, and things of that nature. And then you'll just fill in the blank in a couple of sentences that I have in question 1. My example here is the Eiffel Tower is located in the capital of, well, it's France. Many people consider the practice immoral, but legalized gambling is a significant source of revenue for the state of Nevada. So that's the kind of thing that you'll do in question 1. In question 2, you have to identify notation symbols. So just study these, find these, and make sure you remember what they are or what they mean. And distinguish between a sample and a population. For instance, this is lowercase sigma right here. Okay, I can't highlight it. Right here that I'm pointing to, that's lowercase sigma. That's the standard deviation of a population. Lowercase s is the standard deviation of a sample. In addition to this, I'll have the symbols for percentile and quartile, which we'll see later in this review. And just remember that capital P subscript 47, refers to the 47th percentile. So when you see that on the test, don't just simply write percentile. Identify it as the 47th percentile. Okay, the third question just asks you to identify some of the characteristics of classes that are used to create or that would be used to create a frequency distribution. The lower class limits, and of course, as you can see, this example comes from the slides, and it comes from another set of data. It comes from the IQ scores of children who were exposed to low levels of lead. These are on the Chapter 2 slides, which I have uploaded onto the Canvas website. But the lower class limits are the lowest values that can belong to any one class. So they're 150, 155, 160, etc. And the upper class limits are the largest values that can belong to any one class, like 159, 164, 174 here, or 214 here. And so you can see that shown in the example. Excuse me. Now the class boundaries are the midpoints between subsequent or adjacent lower class limits and upper class limits. So the upper class limit that is adjacent to 70 is 69. So the upper class limit is 69. Its subsequent lower class limit is 70. So if you add those two, 69 plus 70, and divide by 2, you get 69.5, which is the midpoint between that lower and upper class limit. As you can see down here, the class width is the difference between two consecutive lower class limits or two consecutive lower class boundaries. So 70 minus 50 is 20. That's the class width. 129 minus 109, that's, what did I just say? It's 20. Sorry, the class width is 20. And so if you add 20 to each of these class boundaries, then you'll get all of the other class boundaries. 69.5 plus 20 is 89.5, plus 20 is 109.5, plus 20 is 129.5. Don't forget this last boundary, which is actually outside it's larger than the highest value, the highest upper class limit for the largest class. And similarly, don't forget this lowest class boundary. It's just below the lowest score, or excuse me, the lowest value in the first class. And we find that by just continuing the pattern of plus or minus 20 from any one value. Now the class midpoints, oh dear. Sorry. The class midpoints are the mean of the highest and lowest values in any particular class. That's 50 plus 69 divided by 2. That'll give you 59.5. That's exactly halfway in between 50 and 69. So for this class, that's 59.5. To find the other class midpoints, you just add 20, add 20, add 20, add 20, and so that gives you the midpoints for each of these classes. And as I mentioned before, the class width is the difference between consecutive lower class limits or consecutive lower upper class limits or consecutive lower class boundaries. Or for that matter, upper class boundaries. So here's a list. Here's how you might represent them on the test. Lower class limits begin at 150. Next is 155. Next is 160. You don't have to write them all if you don't want to. If you do, that's fine. You have plenty of room. But after you've written a few that establish the pattern, you can just put a set of ellipses, dot, 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 and then another comma, and then the highest value that belongs to that particular designation. So here's the lower class limits, here's the upper class limits, here's the class boundaries. It does say in the question to justify your answers either verbally or with arithmetic calculations. That may not necessarily be necessary, but on the test. But anyway, this is kind of what I was talking about. Here are subsequent upper and lower class limits, and added together and divided by 2, and that gives you one class boundary. The class midpoints are calculated like so. You don't need to do this for every single one. You just do it for one and show the pattern, and that's good enough. The class width in this case is actually not 160 minus 150. So let me fix that. It's 160 minus 155. So the class width in this case is 5. And you could have arrived at that with by subtracting any two subsequent lower class limits or any two subsequent or consecutive rather upper class limits. So 159 minus 154 would get you 5, and so those are that's the class width for this particular distribution, for these classes in this distribution. Now here's the next question, question 4, and I made a little change to the paper, to the practice exam that I handed out. Actually, so class width for these is 10, and so the upper class limit to the A class would not be 100 as it was on the paper. It would be 99. And the lowest lower class limit would not be 0 as it was on the paper. I mean, of course, practically speaking, you could make lower than a 50 on a test, but to correspond to all the rules of a frequency distribution, this lower class limit would be 50. So these are indicated on the test. They're already there for you. What you have to do is these calculations right here. And the calculation, this question asks for a histogram, a distribution and a histogram of relative frequencies, a relative frequency histogram. So you'll need to label this column relative frequency, and then you find each of the relative frequencies. And you do that by adding all of the frequencies so that you find the total. In this case, this was 22. And then you divide the frequency of each class by the total to find what proportion and therefore what percentage that is of the total values. So here we have frequency of 4 grades in this class, a total of 22 grades. So 4 divided by 22 is equal to 0.18181818. It doesn't terminate. We round that to 0.18 and move the decimal 2 places to arrive at 18%. And in the same way, we divide 7 by 22. We get 0.3181818, and you round that to 0.32. Move the decimal 2 places, and you get 32%. Same thing for 6 over 22. This rounds to 27%, and of course this class, there are just as many D's as there are A's, so that's 18%. And the last class, the F's, the poor lone soul who got an F, which I hope is none of you, is divided by 22. That gives us 0.045. Because this is a 5 here in this place, we round this up to 0.05, move the decimal place 2 spaces, and that gives us 5%. So all of these percentages should add up to 100, and they do. If they don't on your test, but they come very close, you probably shouldn't agonize over it too much. Don't spend all day trying to figure out why or how you could make them add up. But they should add up to either 100% or very, very close. Now, to draw the histogram, remember these go from 5% to 32%. 32% is the largest value. And so the scale on the diagram that I gave you here goes up to 35. So these are percentages. The y-axis will be the percentages that each class represents. And you would want to label the classes, in this case with class boundaries, 49.5, 59.5, etc., all the way up to 99.5. And then for the height of each bar, you just mark, you draw a line that's level with this value here. 5% is marked here. 18%, here's 18, 15, 16, 17, 18. So you just mark that bar, the top of that bar right there. 27%, here's 25, 6, 7, so you mark the top of that bar right here. And then you can shade in the bars however you want. You don't even really need to do a whole lot of work shading them. You can just draw some hash marks, or if you feel like entertaining yourself, a bunch of little hearts or bugs or whatever. Anyway, so fill them in however you want. You don't have to label the x-axis with the class boundaries. If you prefer, you can label them with the class midpoints. Put those right in the middle of each class if you do, as I have done here. Okay? And as I said, the blank graph on the exam will have the same scale as this, because your answers will be in the same general ballpark as these percentages. Now, it also says on the practice exam, is this distribution skewed, and if so, how? Well, this one is skewed left just a little bit. I mean, it's very slight, but it's fairly normally distributed, and so you could interpret that way. In this particular case, I would take either answer. Either answer would be fine. Now, excuse me, for question 5, we have a supposedly random sample of 10 midterm exam scores from a class of 100 American history students, and we're asked for the range, median, or the range, mean, median, mode, and standard deviation of the data set. So here are the values. They are arranged in order, and so finding the median would be really easy. It's an even number of values, so you would take the middle two, add them together, divide by 2. The mean would require more work, and the standard deviation would certainly require more work. The question on the exam has smaller numbers, and it's still workable with just a calculator, but for the practice and for the actual exam, I've provided an Excel spreadsheet that has all these values in it. And you can see here where it says question 5, exam scores. This means that the column to the right of that has the values that are represented on the question on the exam. So, as part of your notes, make sure you include the Excel formulas, and it should make for your note sheet. And they're on the Chapter 3 handout, and that should make life a little easier for you. Now, again, as I've mentioned before, I have a Mac, and so my version of Excel does not look exactly like the ones in the class. It doesn't look exactly like yours, but it'll do all the same things in the same way. So, we want the range. We know how to get the range. Subtract the smallest from the largest value, and we also want the mean. Okay. Well, in Excel, the command for mean is average. So you type equal. You must have the equal sign for Excel to know that you want to do some calculations, and then you type the word average. Then, when you do, and you can do it lowercase or uppercase. Once you're done typing that word, you type a left parenthesis, and now you can see how Excel prompts you for your data values. Well, you can type them in one at a time, or what's much easier is to select the entire array. Remember, a set of values is an array. And I will do that by clicking and dragging down from the top to the bottom value. If you prefer to type B2 for that first cell, and then a colon, and then B11 for the last cell, you can do that. Once you've done that, close your parentheses and type enter, and that is the mean for this set. We saw earlier what the median would be. It would be 80 because that's 78 plus 82 divided by 2. So for that, you type equal median and your left parenthesis. And I'm not clicking and dragging this time because I know this is going from cell B2 to B11. I just type B2, a colon. Don't type a semicolon. Excel won't know what you want to do. Type a colon and then B11. And close your parentheses and hit enter, and so there's your median, 80, which is just what we knew it to be. If we ask for the mode, we'll get 82. It's the same formula, equal mode, equal MODE, and that's going to be B2 to B11. It's the formula that's listed on your Chapter 3 handout. And now finally, we do want the standard deviation, and that formula is equal STDEV. STDEV, and you have several choices. And remember, as I mentioned, the two that have yellow triangles, which they don't have in my version of Excel, but the two that have yellow triangles are the versions that are compatible with prior versions of Excel. So STDEV, left parenthesis, B2 colon B11, or highlight them as we did in the first example, close your parentheses, hit enter, and the standard deviation is 13.4825. You can round that to 13.5, but if you don't, you're certainly not going to lose points over that. When you enter all of that information onto your exam, please make sure that you write the Excel formula down if you used it, so that I know that you, so I know that that's how you got the answers, and that will count as your work for that question. So that's the end of that question. And for the next one, question 6, we're using this distribution, the same distribution we used for for question 4, and this is going on a little longer than I had hoped for. So I'm going to stop this video right now. Before I do, I'm going to point out that this is not going to work quite right unless I put 50 as my lower class limit for my first class. So I'm making that change, 50. And I'll be back, or I'll resume this with part 2 of the review.